Today, like I promised, I was going to give you guys some supplemental material for the Dijkstra's algorithm. And to do so, right, the first thing we're going to do is we're going to review very quickly what a path length is and what a weight of an edge is. So, if you'll remember, the graphs we've been looking at so far before this last day looks something like this. We got our vertices, in this case A, B, and C. We have edges connecting them, right? One edge between A and B, another one between B and C. So the thing that we've been adding is a weight to each of these edges, right? That's going to be a number that we assign for it. For some examples, that's just going to be a flat number. For other examples, it's going to be a cost, right? A distance in miles, something. So I'm going to add a few numbers here. We're going to try to figure out what the weight of this is. Right, so the question I'm going to ask is, what is the weight or length or value or any word that comes up of the path A, B, C, right? Which in this case is us going from here over here. And so to do that, it's nice and simple, at least this part. And we're just going to add all the edges that we crossed over. We're going to add all the numbers attached to them. So it's going to be 15 plus 7 for 22. So that's the weight of this path, right, or the length of this path. Now, if you remember, right, one of the questions we really want to ask is, given a graph, and what is the shortest way to get there? Right, if I want to go from one point to another, what is the shortest path to go from one point to another? Right, in some cases, we could just see visually. If the graph's simple enough, we could do it by hand, but they're not always very, very simple. And so we're going to use that thing we were talking about called Dijkstra's algorithm. And so I'm going to draw a graph here as a first example, and then I'm going to have a few other examples in separate videos that I'm also going to be uploading. So let's say we have this setup. Right, I'm going to draw this graph right here. Go over here, 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 and here. Okay, and now let's say that the setup we're looking at is this. Right, I want to fly from LA to New York in the shortest amount of time possible, but I have to deal with connecting flights. Right, and if you remember, connecting flight, when you take long, plane rides, that's always just going to be when they send you from one airport to another, because maybe they don't have a direct way of going from LA to New York. So I'm going to mark my vertices. Right, LA, New York, and say that, to get there, they're probably going to send me over to Denver, and they might send me to Las Vegas. Okay, and then I'm going to add the weights, right? In this problem, these weights are going to be hours that it's going to take to get there. So let's say flying from LA to Las Vegas is 1 hour. LA to Denver is going to be 5 hours. Denver to New York is going to be 3 hours. Las Vegas to Denver takes 2 hours. And Las Vegas to New York takes 7 hours. Okay, and so the question for me is going to be, how can I plan my trip so that it takes the least amount of time possible? To fly from LA to New York based on what I have here, right? How long it takes to go from any of these airports over to New York. And what we're going to do is that we're going to apply that Dijkstra's algorithm. So the first step is figure out where you want to end up, right? Which vertice do we care about? This problem specifically wants us to go from LA to New York, which means that we're going to mark down this is our ending. Right? We want to end up here. So I'm going to mark it with baby blue, right? Just to mark that this is our end. Okay. Now, quick note. Somebody mentioned in class, why can't we start at LA and go to New York? Looked into it. Turns out you could. It's just for this class, the way they like teaching it is this backwards idea. Right? Both are going to get you the same exact thing as long as you follow the same rules. Okay. So we're going to start here in New York, and then we're going to add those numbers I was talking about. Right? You'll see it in the textbook. They have a number that looks something like this. We got square brackets, and something's here in the middle. So the number we're going to ask ourselves, right? This mystery number is going to be the distance from New York to New York. Right? Anytime we add a number is going to be the shortest distance from a point to New York. So later on, when we add a number to Las Vegas, right, at that step is going to be the shortest time to go from Las Vegas to New York. But I mean, New York is New York, so distance is 0. Right? It takes 0 time to go from New York to New York. If you're in it, you're in it. Okay. Once we've marked down our ending one, right, we want to check what cities, what vertices, is there an edge, connected to? Right. New York has 2 edges coming out of it. So let's see what cities, are those edges that it connects to. Right, and that's going to be Denver. That's going to be Las Vegas. And so for now, I'm just going to keep these in mind. Okay. So for all these problems, you're going to end up with 2 scenarios, right? You're either going to start talking about a vertice that has no number, or you're going to have a vertice that has a number already. So question here, does Las Vegas have a number? Yeah, and you can think about it, right? Maybe put on some nice music while you think about it. But the answer is, I haven't given it a little box yet. There's no little box with a number in it. So I have to give it a number, and the number I'm going to give it is going to be the number here, right? The number that this point is attached to, plus the value of the edge that's connecting the 2 of them. So in this case, I'm going to put down here 7 plus 0, which, 7 plus 0 simplifies out to just 7. All right, and then I'm going to mark this edge because now we're never going to talk about it again. Right? We're done talking about this guy. All right, let's look at the edge connecting New York and Denver. Right? Does Denver have a number? And the answer is going to be again, no. Right? I haven't given it a little nice box number. And so I'm going to do the same thing. Right? It doesn't have a number, so I'm going to add the edge that we're looking at plus the number attached to the other vertice. Right? New York has a 0. This edge is 3, so we're going to give it 0 plus 3, which is the same exact thing as just calling it 3. All right, and we're going to mark down this edge. Now you'll notice that what we did here is that we've marked all the edges connected to New York, so we call it visited and we cross it out. But we're not going to talk about this guy anymore. Okay, so that's the first, couple steps. The final, or the step we're going to be repeating is this. We're going to look at the vertices that we just talked about. Denver and Las Vegas, right? We're not going to talk about LA right now because, it wasn't connected to New York, right? We're going to talk about the ones immediately connected to the vertice you were talking about. So we're going to analyze these 2, check these paths, right? And then move on. So the question is, out of Las Vegas and New York, which one do we pick to talk about next? And our choice is going to be whichever one has a tinier number attached to it. So Las Vegas has 7. Denver has 3. So 3 is smaller than 7, so we're going to look at Denver first. Okay, same process, right? We're going to mark all the edges attached to this thing that we haven't, marked in blue yet. So this guy, right, we already talked about, so we're just going to mark you. We're going to mark you. We want to talk about these guys. Okay, and then here's maybe the bit of the confusing part, right? So these numbers, or we're going to be talking now about LA and Las Vegas, but LA doesn't have a number, right? That one's going to be nice and chill for us to talk about. The harder one to talk about is Las Vegas here. And this is the case where you have to maybe replace numbers. So what we got to ask ourselves is this. Is it faster for Las Vegas to keep its current path to New York, which is this, or is it faster to take a detour through the point Denver? And the way we're going to check if it's faster or not is we're going to see what's the total value of this path. So Las Vegas to New York, right? We know that's 7. And then Las Vegas to Denver to New York. Well, let's fill in what we have. We have a 2. We have a 3. What's the total weight of this guy? Well, it's going to be 2 plus 3 or 5. So the question is, what's faster, right? Taking 7 hours or taking 5 hours? And the answer is going to be taking 5 hours, right? That's going to be a lot faster for us. So since we found out that going from Las Vegas to Denver to New York is faster and it takes 5 hours, we're going to replace this number right here. Yeah, and what are we going to replace it with? We're going to replace it with 5. Whoops. Okay, let me mark this down real quick and put our new number in here, which is 5. Okay, so we finished looking at this edge. And remember, if this number that we found, right, say instead of a 3, this is a 10, and a total weight of this is 12, we would have kept that as a 7. Why? Because we only change when the number is smaller. Okay, so we've talked about this edge. We talked about this edge. Now we got to talk about this one. Now, question, right? Does LA have a number? And the answer, like the other guys, at the first time, is going to be no. Right? I don't have a little box number. So what do I got to do? I'm going to add the value of the edge I'm looking at, which is 5, plus the value of this guy up here, which is 5 plus 3. That's going to be 8. And we mark. We're done talking about that. So we talked about all the edges connecting to Denver. We're going to mark it as blue. We're going to say it's visited, and we're going to move on. We're going to move on to Las Vegas. Okay, Las Vegas, right? We can't talk about this edge because we already looked at it. Can't talk about this one because we've looked at it. Only one that's left to talk about is this fella right here. And what we're going to do is same thing, right? We're going to check. LA has a number. Do we have to replace this? Now, we're only going to replace it if going from LA to Las Vegas is faster than we already have, right? We already have this path. We found out that has a length of 8. And so the question is going to be, if we go to Las Vegas first, right, we do this, is that faster than 8? And how do we check that? We're going to add, again, the edge that we're looking at, plus the number of the city. And so that's going to be 1 plus 5. And we draw the paths, right? Right now we're debating whether or not we do this. This is Denver. This is New York. We're trying to pick between this guy in orange and this other one, which is LA to Las Vegas to Denver to New York. Right. We said over here, right, that the weights are 5 and 8, or sorry, 5 and 3 for a total of 8. And over here we have 1, 2, and 3. 1 plus 2 plus 3 is 6. So this guy has a total weight, length, we'll say length of 8, and this has a length of 6. Good. 6 smaller than 8. So what we're going to do is that we're going to replace this number with our new smaller number that we found, which is 8. Or sorry, which is 6. Right, and then we're done talking about this. We're done talking about Las Vegas because we already touched all the edges it's close to, or that it's directly connected to. We're going to call it visited, and we're going to be done. And so we're done with this problem, right? We've looked at every edge, and what did we find? We found that the fastest path from LA to New York is this guy right here. 6 hours. And it takes us from Las Vegas, or LA to Las Vegas to Denver to New York. All right, this is the first example I want to talk about. I'm going to keep talking about other examples in other videos, but for now, this is it.